So you're all being recorded, and this is 10:08. Go ahead and advance the slide, please, Linda.
Okay.
All right, this is what I have planned for tonight. I'm going to talk about what kind of grace notes you're going to have, and I say and such, because you're going to have the grace notes, but you might have something else. The grace notes are going to be attached. That's all you got is the grace notes, but I think that will be plenty. Okay, so that is good. So we'll go over that. That will be the first thing tonight. Then we're going to remind you about the low stakes assessment that is out there for you to do. And then we're going to remind you of all the broad support, academic support, that's available for you to, to help you prepare for this upcoming exam. This next thing is going to be your questions and answers, and we'll spend, as long as you really want there. Maybe I shouldn't say that, but we'll spend, time there, certainly. And then I have some questions, and I think I put 6 problems there, and I think we'll do 3 or more of them, and we'll see how that does. And if we don't get 3 or more done, that's okay. You know what the problems are, and so on and so forth. So that's what we have planned for tonight. Linda, go ahead to the next one, please. Okay, so we're going to talk about grace notes and such. And these will be things that will be appended to the back of your physical exam. And so these are notes that people know you can look at and things like that. But you don't bring in your own notes. These are notes that I provide for you. Okay, Linda, let's go to the next note then. Okay, now you might say, what the heck is this? I hope not. I hope you're saying, oh yes, I'm glad I have that. Linda, just so you're doing something besides punching the slides, and again, you do a lot. You do actually much more work than I do on these things. But anyway, Linda, what the hell is this, and why would a student might be interested in this? And by the way, if we were really in a real classroom, I wouldn't ask Linda to do this. I'd be staring at you guys, and I'd say, okay, somebody tell us. But anyway, Linda, go ahead.
This is your standard normal distribution table. So it gives you probabilities when you put in z-scores or the other way. So you'll need this for quite a few problems.
Is there anything else on this page, Linda, that might be of interest to the students to point out?
On the bottom left-hand side, you'll see the confidence interval critical values. Those will come in handy with your confidence interval problem. Those values can also be found in the table, though.
Okay, and that is good. Let's look at the next thing.
So more of the same, but negative.
The last one was the normal table. What is this?
So this is the left-hand side of your normal distribution.
And what 2 ways tell you that is what this is?
So you can see that from this picture here, as well as the title of it, and you'll see negative z-scores along the side.
Okay, excellent. Thank you so much. Let's go to the next slide. What the heck is this, Linda?
This is your t-distribution table, which we have not quite used yet.
Well, we're going to fix that tonight. Okay.
Yes, we will.
Okay. And I think, now, I'm pretty sure I used it in the videos that I posted, I think. But you're right, we haven't used it tonight in our class, but we will. Okay, and Linda, I don't know, you might have one of these things laying around. Oh, yes, thank you, Gina. I was thinking I did. I think I did work some problems with this, but we will work some tonight too. And Linda will be, providing commentary. And Linda, this might be the only copy of that you've got, so kind of remember maybe what slide that is or something, because you might end up going back to that.
Okay.
All right. And let's see, what is next?
So your critical values for correlation coefficients, this is what tells you if a line is good enough to use.
Okay. And again, well, on one hand, I'm not being super careful if I have to cut a lot of things out, but I probably wouldn't have thrown this in the grace table, grace notes, unless there's a reason to know about this. So, okay, so that's good, Linda. Let's see what else we have in the grace notes. Now, this is, and I call this this thing grace notes and such. This is the calculator that you are going to be allowed to use. Now, what I threw up here was the calculator that is on the PC that I was working on at the time. And you can use a calculator on the PC, but they're not going to let you go out to, I don't know, some website and do that. Or at least if they see you doing it, they'll say, well, wait a minute, you're not supposed to be doing that. So this is the one you want to use. Now, you might say, well, gee, I have a better calculator than that. Well, maybe you do. But some people don't have calculators at all, and I want this to be kind of a level playing field. And you all have access to Excel, which I got to tell you, I wouldn't even touch this myself. I would just use Excel. But this is available for you, and this is the one they're going to think that you can use. Okay, so that's what we've got there. And so I said this was grace notes and such. That's just, I wanted to show you a picture and things like that. And by the way, if I were a student and I'd never used this before, I said, oh, I want to, figure out how this thing works before the exam starts. Okay, let's go to the next slide, Linda, please. Now, Linda, and by the way, if I ask you something you're uncomfortable with, let me know and I'll chime in, because I made up these slides and we obviously didn't rehearse this. But what is this about, do you think?
I believe this means they get to use Excel, but they can only use a blank workbook if they're being honest.
Yeah. And what do you think that blank document up there is about that I didn't say anything about? But it's not a workbook, it's a document.
So that is what they will be copying and pasting their charts and graphs into to submit after the test is over.
Now, but Linda, that gives them a Word document, and what they're supposed to be doing is sending in PDFs. So what happens to make that happen?
So they just save it as a PDF.
Okay. Now, suppose they're a person who wasn't printing this out at all, which certainly they can do. Is there anything else on this page that they might want to think about?
Well, you have Office Lens, but I'm not quite sure how they would use that.
Well, okay, and that's fair. I find that young people take pictures of so many things. So what you can do is you can take a picture of your screen with those charts on it, and you can use Office Lens to change the JPEGs into a PDF and upload it. Now, after I've said that, Linda's probably going to say, yeah, but what I said was easier, and probably is. But I was making this slide without the benefit of Linda's counsel, and also I was thinking about cookies at the time. So anyway, that's what we've got there. Linda, let's go to the next thing, please. Now, this is Formulas O'Plenty, and this is going to be in the grace notes. And so you're going to have access to the stuff that's here and nothing else. And so if there's something that's not here that you think, you need to know, you're probably memorizing it. And so these are a bunch of formulas that we have, and you see standard deviations and, well, many, many, many formulas. Let's go to the, and it does make a difference whether something is a sample or a population. You see there's differences there. Linda, let's go to the next slide, please. Hey, this is more formulas. And now those first ones were about means and standard deviations and populations and samples and, business like this. What is this business about, Linda, here, these kind of formulas?
So this is for your correlation coefficient and coefficient of determination. So this is when you're working with a linear regression.
And Linda, these are nice formulas, and these really are the formulas. But what can the students do if they don't want to, or if I'm not creating a situation where they have to do this calculation? Does Excel have formulas for this?
It absolutely does.
Yeah. Actually, I don't know if it has. I'm pretty sure it does have one for r squared, but I don't know where it is. I probably just find little r and realize that little r squared for lines is big R squared. Okay, Linda, let's go to the next slide, please. Wow, this is a bunch of formulas, okay? And so these are the probability formulas that you have, and it talks about combinations and permutations. And so, Linda, do you think they need to use those combinations or permutation formulas? Let me say it a different way. Do they have to calculate it using those formulas?
No. They can absolutely use Excel.
Okay, excellent. And again, Linda, we didn't rehearse this at all, so I'm not trying to play games. I'm just trying to amuse myself, I guess, a little bit. But hey, why did I not put Bayes' law on?
Because they should just make a tree.
Yeah, you just draw a tree, and that's even what I tell my people who are supposed to know more math than you guys are supposed to know, but because it's hard. So very well. That's excellent, Linda. Let's go to the next slide. Wow, even more formulas. Let's see. Looking at the top, that's the z-score. And on the other side, what happens is we've solved for x. So you remember that the z-score equation measures position, and that takes you from x space to z space, among other things. And then there's two great questions, and those formulas answer the two great questions. At least, well, they help you answer the two great questions. Now, Linda, I'm going to ask you, and I'm not expecting you to give a 20-minute lecture on this, but there's some other formulas there, and so it will take me longer to figure out how to turn this off. I'm going to mute myself, and Linda will talk a little bit about this, and I'll be right back.
Okay, so these are your formulas for going from x space to z space and back again. And then let's see, we also have mean and standard deviation of a sampling distribution. So I believe we're going to talk about those more tonight. The sample proportion is how we find p-hat for your confidence intervals. So all of these come up with the confidence interval stuff, which I actually believe is on a later slide as well.
Okay, so that is, but certainly we're going to be using those on a later slide. Okay, so that is, oh, no, I think Linda is right. Now, and I was dealing with that call that was coming in for a moment. I basically told them that I was giving priority to my students, so I would have to call them back. Maybe Linda said this, but another thing that happens, and I think I threw in some problems about that, when we're talking about the sampling distribution of the mean and the sampling distribution of the proportion, I did give you lectures on that. These do come up in those kind of problems too, and we might even have more than one problems where we do that. Okay, Linda, next slide, please. We're burning a lot of paper on these grace notes, aren't we?
Yes, we are.
I guess we're only burning paper if people print them out. But anyway, there's going to be these things. They'll be at the back of your exam, and that's going to make the physical exam look like a lot of pages. Okay, I think Linda, yeah, this is what Linda was talking about, and so we have these, confidence intervals information here. Okay, Linda. Oh, and I guess I'm going to say over here. And by the way, we did do a lot. We did everything we're supposed to. This piece of stuff over here, I don't know if you can see my cursor or not. But anyway, this stuff that's on the left-hand side is not something you'll need. And I'm not trying to confuse you. I just didn't take the time to, cut that out. This is something that's good. If you want to learn about this, you can take Math 1635 with me or with somebody else. Okay, so Linda, next slide. Oh, now, Um, and again, I really wish we had a class because I asked, what is this, or why is this here? And the reason this is here is at the part of the agenda where I'm reminding you about the low stakes assessment. And I think, and I did check, this is the low stakes assessment. Okay, so we've got some data here, okay, and so you have to enter that into Excel, and then there's questions that ask about this, point estimates, 95% confidence interval, and then here's a second sample that you got, and then, it asks some questions about that. So I think this is a good problem, and it helps you. Yes, this is, oh wait, this is the assessment that is due. And Linda, is it Saturday?
Yeah, Saturday at 11:30.
Excellent. Okay, so it's due there, and you don't have to worry about things being there because Linda took that on because I proved myself incapable of doing that. Okay, so doing that in a timely way. Okay, so that's the low stakes assessment. I've reminded you of this. I think it will be good for you to practice this. And think about this. You're practicing really two things. You're practicing the skills that, the mathematical skills, and you're also practicing the protocol skills about, oh, how do you submit something to the answer sheet? And there's even a password, and you have to say, well, where do I find the password? And I think I'll ask that question of you later. But anyway, those are around, and I'm trying to get you used to what we're doing on the midterm, so you won't be confused about that. So that's the LSA reminder. Okay, Linda, let's go ahead. And I said I was going to remind you of what academic support is available. So Linda, what does GSG stand for?
GSG is Guided Study Group.
And who do they get to talk to there?
Me.
Okay, and I, off the top of my head, I can't, well, I think you maybe do it before this class. Is that true?
Yep, 5 to 6 on Tuesdays and Thursdays.
Okay, so that's should be easy to remember and, fit into, certainly the VCM folks' schedule. So that's a good thing. I don't know what DVA stands for. I know it's not DVA, it's DMA. I keep thinking about, I don't know what I keep thinking about, but something about veterinary medicine. But anyway, the V is DMA, but that's Tom Topol, and he, I know, has worked with some of you students, and he has dedicated times, and he's shared those with you many times, and maybe if you looked at this video, he'll share them with you again. But he's available, and that's yet another thing that you can do. Office hours are my office hours. My office hours are at 6:30 to 7:30 in the morning, and they're at 7:30 to 8:30 in the evenings. And so it's shortly after this class, and there's Zoom addresses and things like that that we've shared previously. And the Learning Commons is open 71 hours a week, and they have hours 7 days a week. So that's another very useful place for you to go. And I want to tell you guys that Linda and I have not we have not closed or done any constraints on the Collaborate Ultra thing. So if you have somebody like-minded in the class who you like to study with and things like that, you guys say, hey, let's just go to the VCM website and Collaborate Ultra. Now, I guess you can get into Collaborate. Other people could get in there too. We haven't parsed it into multiple rooms or anything, but if you want to go there, that's a place that you can go to study. And Linda, I am not 100% sure if we set one of these things up on net, so I'm going to have to check on that, and I'll try to remember to check on that. Let's advance the slide.
Okay.
All right, we're going to go through. We're about ready to open it for questions. And I'm watching the clock, and so we're going to do this a little bit differently. I'm just going to say, and by the way, these questions I'm asking for people from the VCM class only to think about this, because you see the answers actually are different about the time and the Zoom address and everything else. So what I'm going to do is I'm just going to go through and read these questions. And if you say, oh, yes, I know that, I really know that, then that's fine. If you don't, when we go to the questions, you ought to be asking them. Okay. In fact, Linda, I'm going to do this differently if you don't mind. I'm going to just read the question and then ask you to answer it for the students, and then we'll have an opportunity for other things. And again, Linda, I realize we didn't rehearse this at all, but it's more fun this way, right?
Oh boy.
Okay.
Sure.
Okay. When, and again, the answers that she's going to give are about the VCM class only. When do they come for the test?
5:45.
5:45. Now that's so you can check in, and so that's good. Okay. Where, I probably should have put, quotes around the where, because you're not coming to campus or anything like that. So where do they go?
I believe they're going to that Zoom link.
Yes, but it's that Zoom link. But I'm going to tell you, it's not, well, it's not necessarily the same Zoom link that we did the other night. So Linda, can you memorize what slide we're on, and then just go to the very end of this? And I think the address is there. Yes. Now, you might tell me that's the same as what we had before, but I'm guessing it's not.
Yeah, I don't think it is.
Okay. But anyway, and that's in an announcement, I think. And we should check on that, but I'm pretty sure that's in an announcement. So that's where you're going. Now, this is for VCM people only, because the net things will be being proctored separately. You will have identified proctors, and people have probably sent you emails about the addresses there. But this address is for VCM only. Okay, Linda, if we can go back to wherever we were. Okay. What do I need?
So you'll need a laptop to be looking at the exam on and to submit your answers. You'll also need a phone to kind of set up so the proctor can see you, your laptop, and your work area.
And what do they need loaded onto the phone?
The Zoom app.
Okay, very good. And actually, you probably need a quiet place to take it. You maybe need somebody to watch your kids if you've got kids. And, if you're blessed having children, that's good. I hope you're doubly blessed and have somebody who can watch them on occasion, because 24/7 with a kid is a lot of tax. But anyway, okay. I guess that's good enough. How long is the assessment, Linda, without accommodation?
75 minutes.
Okay. Where do they find the assessment themselves, the test itself?
I'm assuming it'll be posted in the syllabus tab as well as emailed out to everyone.
That's the plan. That is definitely the plan. Suppose a student wanted to know, where do I put my answers?
You'll be submitting them in the assessment tab, just like we've been doing with all the other assignments.
And you practice it. You're good at this. My goal is there should be 0 process failures on this. We'll see. Where do I upload graphical answers or work?
Those will be submitted in the PDF upload tab, just like how we've done everything else.
Okay. And did I skip the question about how long is the assessment without accommodation?
Nope. 75 minutes.
Okay, that's good. And the clock starts when you put the password in, and your proctor gives you the password. Okay. I think we're down to how long do I have to do that? And that's talking about uploading your answers.
So you have 30 minutes after you exit the Zoom session.
Okay. There is a password, and you'll find that when they've checked your environment and everything. And what if I can't do any of this? Well, you will be accommodated, but I got to tell you, I will be disappointed. Now, I will not be angry, but I'll be disappointed if you tell me that you can't do any of this. Okay. And again, that doesn't mean I'll be mad at you. That just means, oh, damn it, we didn't achieve my objective. Let's go to the next slide, Linda.
We have been practicing for about 7 weeks, though, so you guys
Yeah.
should be okay.
Yeah. All right. This is my words for you, and these are intended to be words of encouragement. And these words apply to both VCM and NET because, you know, this is just how your head should be. And Linda, at the end of this, I'll give you an opportunity to say anything else that you want to say. Okay, so here is my advice for you students. First of all, Louis Pasteur it famously said that fortune favors the prepared mind. So prepare for this exam. That's what you should do. Show up on time, and Linda told you for VCM that was 5:45. For the other guys, it's going to be 15 minutes before showtime, and your other they're not tutors, they're proctors. The proctors should have been in touch with you there. Now there are probably going to be other videos. I guess I'm saying that at the bottom. There'll be additional announcements and emails and maybe videos will be provided to help you prepare, but there's going to be no more content. One of the videos that I expect to do is I'm going to go back and find out which of the low stakes assessments I didn't provide solutions for, and I'm going to provide like little video solutions to those. So those would be good to help you prepare, I think. Okay. So show up on time, but then it says manage your time, manage you time.
Close enough.
So manage your time. And yeah, I guess that's close enough. And this thing went weird on me again, so I hate it when it does that. Maybe I can go, holy, let me try it here. There, no, now I'm back. I think I figured out how to do this without logging out and logging back in again. Okay, manage your time. You see, you only got 75 minutes and you got to put the answers in. Now, you can do what you want, but I will tell you what I would do. I'd work the test completely first, but I'd say, oh, and I'm going to be finishing, oh, I don't know, 5, maybe 10 minutes early, and then I'm going to put my answers in, because sometimes you have to think a little bit about how to write the answers, because Blackboard, and again, you've had some experience with this, Blackboard's not, especially math entry friendly. I don't think, I mean, I think it'll work fine, but anyway, so manage your time. And then what I want you to do is do your best. That's all anybody can ask of you. And that's really all you can ask for yourself. But your best is probably pretty good. So why don't you try to do that? Now, additionally, I want you to breathe. Stay calm and do the math. Because that will help you do your best. I want you to know you have a bit of a grade cushion because I'm lightly grading the low stakes assessments. I'm not lightly grading the midterm, so this matters quite a bit. But you're going to be all right. Okay, Linda, you want to say anything for the students?
So just another reminder that the GSG on Tuesday is not going to happen because I have to be in the proctoring room at about 5:30. Your last chance to meet with me, I guess, for tutoring, at least on my schedule, will be from 11 to 3 on Monday. You guys are more than welcome to email me over the weekend, include your number, and I'll give you a call. We can talk about whatever statistic stuff you'd like to. I mean, we're really just here to kind of help manage the anxiety. So this will be okay. You guys are very well prepared for this. It's going to be fine.
And Linda, we will find a way to get you paid for that, to that happens, because that is important. Okay, and Linda,
I'm not worried about it.
Linda provided you some kind of a thing before that was like a topical study guide or something. I don't know. Okay.
Yes.
Let's consider this this finished. Let's go to the next slide. I know we're spending an enormous amount of time for. I think wow. Oh, that's the next slide. Good. Okay, so this is question time. So we'll see if you have any questions, and you might say, well, good, I won't ask questions, we'll just leave. Well, we have other slides that are beyond this. Yes, Joshua.
Linda, you had said that we have, excuse me, we have a half hour to turn everything in afterwards. I thought they said 15 minutes. Has that changed then?
I
I
don't.
believe it was a half hour.
Well, tell you what, and Linda, uh, I might do a little bit of an audit with you. Let's make it a half an hour, okay?
Okay.
Now, and Josh, you might very well be right. Charlotte might have told us that, and I was paying attention, but I was also hungry, and so I was being distracted by that. So what happens then is we'll come back to that question. I didn't catch it all. Linda, maybe we'll look at that and see what the question is. But I will be talking with the tutoring people and sending out other things and stuff like that. And so we'll make it into a half an hour, okay?
Okay.
And Josh, you might very well be right. That might have been what Charlotte said. And my goodness, I hope everybody can do that, in much
I
less
mean,
than
yeah,
that.
certainly a half hour should be more than sufficient time needed.
Yeah. Okay. Okay. So, and Gina's saying it was originally 15 minutes. And by the way, they didn't screw up. I probably said that, but um, I mean, this isn't science. But by the way, we're going to get there. We're going to land safely. Just keep your seatbelts buckled. Okay. All right. Other questions that people might have.
So one is from Paola on when the Zoom meeting from Tuesday night will be uploaded. And I didn't upload it just because we didn't really cover any information on anything. It was mainly just how to set up your camera, which I believe is already covered in another video regarding the proctoring situation. And then where can I find the answer key videos to the low stakes assessments? Those will be posted probably tomorrow by Professor Bradley on YouTube.
Yeah. I mean, um, earlier today I had to write the words my mother used to say to me often, and I still think about them, is the road to hell is paved with good intentions. But that definitely is my intention to be, doing that. I also have some discrete math I have to do. Okay, other questions? Sydney.
Um, I don't know if you know this, so I'm just gonna ask anyways. Tom Topol, do you know if his Saturday is it on Zoom? His Saturday tutoring?
I I'll tell you what I'm going to, and I don't know, and my guess is Linda doesn't know off the top of her head. But what I will ask Tom to do with an email, I'm promising to do a lot of stuff. This is dangerous, but I think I will send it to Tom and say, hey, Tom, can you remind the students of your access mechanisms and times and so on and so forth. Okay. So you're right, Sydney. I don't know that off the top of my head. It is known. It's probably in emails or something, but I'm going to ask him to remind you guys of that. Okay.
Thank you. I appreciate it.
Other questions? Okay. Let's see.
Yes, that is correct.
Okay. Good. Thank you, Linda. Yes, Michaela.
So on Linda's study guide, it didn't have anything about probability. Are we gonna have a problem on it?
Well, here's the deal. There are two great problems in normal distribution, and one of them is given a number, find the probability, and the other one is given um, a probability, find a number. So I would argue that there's probability in those problems
Okay.
for sure anyway. And I think Linda probably did a marvelous job. She always does. I threw over what was the test. And Michaela, if you want me to, I will revise the test to include an extra problem doing that. But I also would argue, and I'm not arguing with you, I'm just saying there is probability in it.
Yeah, no, that makes sense.
Okay, good enough. Okay, other questions? Okay, Linda, I'm going to pretend that they are sated. The questions are sated, and
Okay.
we're good to go. So let's go to this next problem. And okay, and Linda is probably thinking, "Damn you, Professor Bradley." But anyway, there are. I will read it, and Linda might be typing while this is happening. I don't know.
Yep,
Housing
I'm
starts.
typing.
The following data represent the number of housing starts for the predicted for the second quarter, so on and so forth, for a random sample of 40 economists. Okay, so they ask economists for the predictions, and they gave this, and there's a whole bunch of numbers there. Now, by the way, if you encounter a problem like this, where it's just there, you do what Linda's doing. You'd be typing it in. Now, you also could run across a problem where I tell you, oh, there's an Excel file in Blackboard that is like this. And then you can just go get the Excel file and work with it. And let's see, what else should I say? And this came up the other day, but the best way to do this, and Linda might be doing this straight away, is she's probably pounding this into an Excel column rather than leaving it spread out like this. The data doesn't always come the way you want it to. Okay. Now, looking at this problem, there's several steps, and Linda will probably take us through a bit of these steps. But I'm going to focus you on D right now. And D says, this is kind of the big punchline here: construct a 95% confidence interval for the population mean forecast of the number of housing starts in the second quarter of 2014. So when we get down there, what's going to happen is we are going to be using the T-table. And even if we didn't do an example in class, the other day, we're doing one now. Okay, and then that is on the video, Gina said, and I thought it was on the video too. Linda, you done?
Almost. On the
All
last
right.
column.
All right, good. So that won't take very long because Linda types fast and things like that. So the first thing, first thing we want to do is, with Linda's data, is we want to draw a histogram of the data. Now, the reason we need to draw a histogram is there is an assumption with the t-distribution that your underlying population is normal. So you want to have a little sense of that. And by the way, I might very well be asking you something about a histogram anyway, so that's a good review of that for those reasons. And Linda, I think I'm about ready to turn this over to you again. Are you good?
Yep.
Okay. So talk about drawing a histogram.
So first thing is drawing a histogram. So I'm selecting all of my data. And then I'm going under Insert. I want a statistical chart and a histogram.
Okay. Now, this is a little bit of a statistician's judgment. And so when you look at the picture there, Linda's moving it around a bit for you. Okay, now I'm going to say something, and actually I am being very mindful of our time here. That is skewed just a little bit, okay? And that's skewed right, just a little bit, because that's where the tail is. But I got to tell you, this thing is pretty close to being symmetric. And I'm not asking you in this problem, but if you did a calculation, you could figure out what the skewness was or something like that. But this is damn close to being symmetric. And so we're kind of saying draw it, but we're saying, yeah, it's close enough to being symmetric to do this. Okay, Linda, let's go to problem part B, please.
Okay, so we're also getting a box plot. So once again, I'm highlighting all the data. And then just like before, I'm looking for a statistical chart, but now I'm picking the box and whisker plot.
And those numbers are really kind of close together, but what you're checking here is you're trying to see this, does that look kind of symmetric? And if you really looked at it, you would. Now, there is an outlier that's out there, and if you were an analyst, you'd have to say, is there an outlier? And you look at that, and actually, Actually, let's see. We probably would say that's an, I mean, I don't know. We actually have ways of computing that. We have upper and lower fences. Let's don't bother doing that right now. Okay, I'm going to read part C, and then Linda, I'm going to ask you maybe to respond a little bit to part C.
Okay.
Discuss the need for a large sample size in order to use the student T distribution to obtain a confidence interval for the population mean for this, or not. Do you need one, given that we said it looks like this is probably normal to start with?
So I think since it is basically normal, then you're good with a sample size that's less than 30, which is why we can use the T distribution.
And Linda, that was a wonderful answer. And in fact, I almost have, in fact, I never have been less than impressed with you. And that was kind of a, that wasn't necessarily an easy question for me to throw off the top of my head, but you answered that brilliantly, so that's good. And again, you saved me. Okay, now Linda, the number D says construct a 95% confidence interval for the population mean forecast of the number of housing starts in the second quarter. And so I'm going to just give you your head. You do whatever you want to there. You might have to go back to different slides and I don't know what, but go ahead, please.
Okay, so first thing I need to do is compute my sample mean. So to do that, I'm just doing my average formula. And I highlight my data once again. And close my parenthesis and press enter. So that is my sample mean. And then I will also need my sample standard deviation. So to get that, then I'm doing equals stdev.s because it is a sample. Open a parenthesis, highlight my data, and close my parenthesis and press enter. So there's my sample standard deviation. And then we also need to know that n equals 40. And I got that just from counting the number of data points. So now the last piece I need to be able to construct my confidence interval is I actually need that table from our PowerPoint earlier on, the T distribution, which I believe is this one. So I'm copying and pasting it over to Excel. And we are getting a 95% confidence interval, which means the area in the right tail is going to be 2.5%. So I'm looking at that 0.025 for my area in the right tail. And because I have 40 data points, my degrees of freedom is n-1, so that's 39. So I'm looking at the cross section of that 0.025 with 39, and it looks like that gives me 2.03. So T sub alpha over 2 is 2. What was that? 0.023. Okay.
Sydney has a question.
Yeah. So, how did you get the area on the right tail? How did you get 2.5%?
So it's a 95% confidence interval. So we have a 5% error basically, and I want to split that evenly on the left and right side.
Okay. Thank you.
So that's where the 2.5% is coming from.
Okay.
And the super technical reason for doing that, even beyond what Linda said, is this is a symmetric distribution. Okay. Go ahead, Linda.
Okay. Thank you.
And
All
Sydney,
right.
are you good?
Yeah. Yeah,
She's
I'm good.
Okay.
I'm
Go
good.
ahead.
Thank you.
So I'm going to compute our margin of error, basically. So to do that, what I'm doing is equals, I'm taking t sub alpha over 2, and I'm multiplying that by my sample standard deviation. So that was that 75.124, being divided by the square root of n. So that is n to the 0.5 power. So that is my margin of error. Then from there, to get the bounds of my confidence interval, then I'm doing equals my mean plus that margin of error, and then I'm doing equals my mean minus that margin of error. And that would be it.
So your lower bound is going to be the 998, I guess, and your upper bound is going to be the 1046 business. Okay. Yep. Questions of Linda about doing this problem. And now we have done an example of finding a confidence interval for the mean, and we have done something in class, using the t distribution. So questions of Linda on this problem. Yes, Josh.
All right, so not necessarily for this problem specifically, but in general. So say they say give us a 90% confidence interval. At that point, you would use what that would be 5. You'd be using 5% on the
Yes.
t table. Okay.
Yeah, because there would be 5% on either side.
Okay. Perfect. Just a little clarification. Thank you.
Okay. Other questions of Linda? Okay, Linda, apparently that was really a good thing. I thought it was. Okay, let's go and see what we have next, because we do have time to do some more problems here. So
okay.
Let's look at this for a second.
I think I actually did this last time.
Okay, then if they did a problem like this, and they might have done this. I think I left this there, and I told them, they should do it. So let's pretend they did. Let's go to the next one. Now, this next one also was one that I had there. Let's see. Let's do a poll on this one.
Okay.
What kind of a problem is this? And the answers are going to be not confidence interval, but is this a proportion problem, or is this a mean confidence interval problem? I'm going to ask people to weigh in, because you see, you're going to have to read the problem and figure out what it is. So and it comes from reading the problem and thinking about it.
I mean, in this case, it's really just from reading the problem.
Yeah. Thinking is always good.
Yeah.
Okay, whoever was wanting, or who was thinking, okay, so someone's back on the mean again. So Linda, what do you think and why?
I'd say it's proportion, because part A literally says determine a 95% confidence interval for the proportion.
Okay. Now, sometimes it's going to be there, sometimes it's not. In fact, Linda, pretend it didn't say it that way, and it just says it all the time, though. So maybe the fact
it does say it all the time.
Yeah. So I mean, I don't know. Okay, maybe that was a lame poll. I don't know. Okay. we might come back and work this one, but let's go to the next problem and see what it is.
Okay.
Aha. It's the same question about this. What is it, mean or proportion? So Linda's going to poll you again. You guys should be reading it and thinking about this. And it does take you a while to read because, I mean, there's a lot of words there. Okay, I'm okay. I mean, you know, we're getting there. This is a mean problem, and Linda, why don't you point to, if you will, how you knew it was a mean problem?
So we know it's a mean problem because they literally say results in a mean, and they're asking questions about what the mean is. So create a confidence interval for the mean.
Now,
not for the proportion of drivers with a blood alcohol content of something else.
Okay, so I'm going to read this along the way just to give Linda a little bit of rest, but then I'm going to ask her to dive in and do this. Okay, so here we go. A random sample of 51 fatal crashes in 2013 in which the driver had a positive blood alcohol concentration results in a mean, that is blood alcohol concentration, of 0.167 grams per deciliter. That's 1/10 of a liter, I guess, with a standard deviation of 0.010 grams per deciliter. Okay, part A says a histogram of blood concentrations in fatal accidents shows that the blood alcohol contents are highly skewed right. That means that, you know, some people are really driving when they should not be driving, you know, and they should be, getting a safe driver or taking a cab or an Uber or something. Explain why a large sample size is needed to construct a confidence interval for the mean blood alcohol content of fatal crashes with a positive BAC. And the reason is you need the central limit theorem to kick in. And Linda, what's the magic number for the central limit theorem to kick in?
That would be 30.
Yeah, so that would be 30, and so we're above 30, and that means there's enough samples there, or 30 is a big enough number because we're looking at 51, data points. So we're going to be okay doing this. Well, actually, it goes forward, and I'll read part B, I guess. I should read ahead. Okay, there were approximately 25,000 fatal crashes. Okay, so the data was a simple random sample. That satisfies the requirements for constructing a confidence interval because the number is so large. So 25,000 is a big number, okay? And we've got more than 30 things there. But we're still going to be using the T distribution because all we have is the sample data of 51. So then part C, and I'm about ready to turn it over to Linda, and this is determine and interpret a 90% confidence interval for the mean blood alcohol content in fatal crashes, yada, 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 those words. Okay, so Linda, take over, please.
Okay. So I'm sharing my screen right now. So once again, I am picking up my pieces. So first of all, we get a sample mean, and this is given in the introduction to the problem, of, let's see, 0.167 grams per deciliter. So 0.167. And then we also get a sample standard deviation of 0.010 grams per deciliter. So sample standard deviation, that is 0.010. So then from here, we're told that n equals 51. because they say a random sample of 51 fatal crashes. And from there, I believe all we need is T sub alpha over 2. So with n equaling 51, then I'm looking for 50 degrees of freedom. And we're finding a 90% confidence interval. So that means 5% on either side. So I'm looking in this column for 50 on the left-hand side. So that would be right here. So we get 1.676. And then from there, then I'm going to calculate my margin of error. So equals, then I'm taking my T sub alpha over 2 and multiplying that by my sample standard deviation and divide that by n to the 1/2 power. So that is my margin of error. And then to get my lower bound, then I'm doing equals my sample mean minus my margin of error. To get my upper bound, then I'm doing equals my sample mean plus my margin of error. So that would be your confidence interval.
Okay, and and Sydney has a question before we go into the second part of that. Go ahead, Sydney.
I just had a question about the 30. Why is 30, like, why does it have to be less than 30?
That's so the central limit theorem works. You don't need to have any more details aside from that.
Okay, all right. So it's just another rule.
It's another rule of thumb. There's a lot of those in statistics. Sometimes it is annoying. But the other thing that in this class it's not annoying. In other classes it might be. And actually, I was guessing where this problem was going, and that ended up not really being much of an issue for this problem because we were taking 25,000, fatal crashes. So don't worry about that a whole lot, but that is what was going on. Now, this did ask us to interpret okay, someone's just joining the session. Okay. We're supposed to interpret what does this mean? And so, Linda, can you talk about what this confidence interval really means then?
So it means that 90% of the time when you take a group of samples, then the mean will fall between 0.164653 and 0.169347. And this is kind of explained in a video that Professor Bradley shared as well.
Okay, so that is good. Now, part D, I'm going to read it. I'm not, and it's good that I'm reading it because I'm not sure what it says yet. All 50 states and the District of Columbia. By the way, one day soon, my brother predicts D.C. and Puerto Rico will both become states. We will see how good his political crystal ball is. Okay, uses a blood alcohol content of 0.08 grams per deciliter as a legal intoxication level. Is it possible that the mean blood alcohol content of all drivers involved in fatal accidents who are found to have positive values is less than this legal limit? And then we're supposed to explain. And Linda, are you comfortable talking about this one?
Yeah, I would say this is nearly impossible because if you look at our confidence interval, then these values are just about double what they're saying the legal limit is. So it would be extremely unlikely for the actual mean to be 0.08.
Okay. All right, so that's good, unless there are questions. I'm polling for questions for Linda on this solution. Well, Linda, again, that must have been a masterful presentation, so that is good. Okay, let's go back to the slides. I am watching the time for you guys. And Linda, I'll tell you what I'm looking for now is I'm looking for something where we do a probability problem, and Michaela, a probability problem, okay, dealing with the normal distribution, and I think we probably have them. Let's look through them carefully. Not there, not there. Let's see about this. Let's see. Okay, this works, right, Linda? Because we're taking a sample of
Yeah.
that, and we're finding the mean amount spent from the sample. Okay, now can you talk to this one for us then? And let's see, I guess I have enough time to read it, so I am. Okay, hungry or thirsty? How much time do Americans spend eating or drinking? Suppose that a random sample of 1,001 Americans age 15 or older, the mean amount of time spent eating or drinking per day is 1.22 hours with a standard deviation of 0.65. And this is from some kind. People actually do this. This is your tax dollars at work. It looks like this is the Bureau of Labor Statistics. Okay. So part A says a histogram is skewed right. That means we need a large number, but there are over 200 million Americans 15 or older. So that means we're going to be okay doing a confidence interval. And that's some pretty technical math stuff, but that's what is there. Now, number C then, we're to determine and interpret a 95% confidence interval for the mean amount of time, so on and so forth. And could the interval be used to estimate the mean amount of time a 9-year? Well, we'll get to that in a bit. So Linda, go ahead and take over with this and just start with part C. And Linda, as you go forward on this, probably go ahead and work the problem. That's fine.
Okay. So let me share my screen real quick.
And I may be taking back my comment about this being one of those kind of problems. Go ahead. Let's just work through it.
Okay. So we're finding a 95% confidence interval. So I already took the time to type in what information was given to us from the problem. So we're finding, let's see, n is 1001, so my degrees of freedom is just 1000. And because it is 95% confidence interval, then I have 2.5% on either side. So then I'm looking in the 2.5% column, and I'm going down to 1000. So let's see. That would be 1.962. So then once again, I'm computing my margin of error first. So that equals my t sub alpha over 2, the 1.962, times my standard deviation, and divided by n being raised to the 1/2 power. So that is my margin of error. Then to get my lower bound, then I'm doing equals my mean minus my margin of error. And then to get my upper bound, then I'm doing equals my mean plus my margin of error. So that would be my 95% confidence interval.
Okay. Now let's go back and read. I think there's a part D to this.
Yes. So that would be right here.
Part D. Could the interval be used to estimate the mean amount of time a 9-year-old American spends eating and drinking each day? And what I'd like for people to do is to vote on this. We'll do a little poll thingy, and it's yes or no.
Okay.
I want to encourage you to feel free to play, because even if you make a mistake, it's kind of okay, because it doesn't matter.
It's more fun that way.
Yeah. Playing is more fun, and you learn something too if you make a mistake. And mistakes are okay. I make them all the time.
Can you repeat the question?
So, can you use data from a 15-year-old to determine what a 9-year-old does?
And it looks like the no's are winning. So why don't we just declare that a victory for the no's? But that's a correct answer, because your study was about something very different. A 15-year-old is very different than a 9-year-old. Okay. A 15-year-old, well, I'll just leave it at that. You guys, most of you, in fact, I bet all of you are over 15, and that means that you were once upon a time 9, and things were way different, and physically as well as other ways. Okay, so that is fine. Now, Linda, let's go back, and either we're going to see if I did put a problem in there that I wanted to do, talking about the mean, or if I didn't, let's go back and do one of those proportion problems to finish off.
Okay.
Okay, hungry or thirsty. Okay, let's look at this. We can't do this one because this is a binomial theorem one that I didn't. Yeah, okay, here, maybe. Wait, let's go. Let's see. And what's the thing at Burger King?
I think that's also a binomial one.
I'm not sure. I don't think so, because
Yeah.
you have.
I think I was thinking of the Wendy's problem that we always do.
Yeah. I don't think that, I think this might be the problem I want to do. I'm going to read it, and Linda will be, getting ready to do this, okay? Suppose that and I am watching the time for you guys, okay, don't worry. Suppose that cars arrive at Burger King drive-through at a rate of 20 cars per hour, okay? And so that is known somehow. A random sample of 40 one-hour time periods between 12 noon and 1 is selected. And after you do all of these samples, the average of those 40 measurements is 22.1 is the mean number of cars arriving. Okay, now the reason the sampling distribution of x bar is approximately normal is the central limit theorem, okay? And what is the mean and standard deviation? They're telling you that, but we're assuming that mu is equal to 20 and sigma is the square root of 20. Now, often you don't know the square root of 20, but this time you do. That makes this a normal distribution problem. What is the probability of the simple random sample of 40 results in a mean of at least 22.1? Is this result unusual, and what might we conclude? Linda, you have 5 minutes.
Oh boy. Okay.
Do you think that's not enough? Would you rather do a proportion problem, or give it a go?
No, it's fine. I'll wing it.
All right.
Okay. So I believe we were just finding the z-score for what they want the mean to be. So in this case, I'm doing equals. That would be 22.1 minus my mean is, hold on. What did they give us in the problem? There we go. So my sample mean was 20 cars every hour. No, my sample mean was 22.1. They're saying, hold on.
Okay, so your standard deviation is going to be sigma over the square root of n, right?
Yeah.
Okay.
So that would just be sigma, which I already calculated was the square root of 20, divided by n raised to the 0.5 power.
Now, this is the thing, and you saw this in the decisions with data. Linda, don't worry about finishing this.
Okay.
I mean, it's not, I mean, don't worry, it would be rushed. So I'm going to talk a little bit about this. This is what happened in chapter 8. And what happens is when you're taking averages, what happens is the mean stays the same, but the central limit theorem says that the variances or the standard deviations become much narrower. Okay, so you see here where we had the 4.47 and change as a standard deviation. When you take averages of 40, the standard deviation drops by a factor of, wow, better than a factor of 4 and maybe a factor of 5, maybe. Okay, so anyway, it drops way down, and so you end up using that to compute this. Okay, and we can't really finish the last thing because we don't have the number. But anyway, that's an important thing. Let's see. So I think Linda's planning on uploading this. I think we recorded. Yeah. Okay. So that's going to be good. Now, no more new content before midterm. We accomplished what we needed to. We covered everything we were supposed to, maybe then some things. But now what we're going to do is I am going to give you other kind of communications between now and the exam that will help you, get ready for the exam and be good to go. Linda, anything else you think you should say for the group?
No, if you guys run into any trouble over the weekend, feel free to email me and I'll get back to you as soon as I can.
Okay, well, I guess I'm going to poll the students one more time. Any last questions? Okay, so I have a question about the homework. Since there are two sets of data, how do we put it into one? The questions ask about, and I'm not being precise here, but part B might ask about the first set of data, part D asks about the second part of data, and then it asks you how they get together, maybe in a part F or E or something like that. So you do both of them, Estefania. And anybody else who had that question. Okay, I watched the time for you. Time is precious. Each day must count. Do the math, it will make you strong. Thank you, Linda. Good job as always.